The different populations of stars, along with the star-gas-star cycle, actually helps us understand a little bit of how our galaxy formed. Remember that we find population 2 stars primarily out in the halo. That suggests that out in the halo probably formed first because those are the oldest stars. Then we find population 1 stars, the younger generation, throughout the disk. So that suggests that halo formed and then later disk formed. So what we believe happened is that we start out with a giant proto-galactic cloud. So a giant cloud that's going to eventually form into the galaxy. This is going to have a high enough density and a low enough pressure that it's going to collapse under its own gravity. Then as it collapses, there's going to be pockets within it that then have star formation. So we have stars form all throughout this entire thing to begin with. That's going to be our population 2 stars. Now, if the star formation rate is slow enough, then there's still going to be a lot of interstellar medium that gravity's pulling in on, so that stuff is going to continue to collapse. But remember, because of conservation of angular momentum, this material, as it shrinks, is going to rotate faster. And because it's rotating faster, it's going to kind of bulge out. It's going to stay puffed up in that plane of rotation. But in the other direction, gravity's going to be able to keep pulling it down and down and down until we end up with a flat but broad disk. And because that's where the interstellar medium is, that's where we're going to have ongoing star formation. Now, something I want to point out, although this works very nicely, it's not what we actually see happening. It appears that galaxies the size of the Milky Way did not form from a single protogalactic cloud. Instead, it appears that there were several protogalactic clouds which had already begun star formation, which then merged together. Now, as they merged, any stars that had already formed would be thrown on wild and chaotic orbits, again creating that halo component, and then the interstellar medium from these would be able to continue to collapse, forming into the disk. So it's still definitely a related idea, it's just not that we had one giant cloud. Instead, we had many smaller clouds that merged together. Now, we think that our galaxy likely has nicely pronounced spiral arms. We don't know for certain because we live in the middle of it and we haven't been able to get out to actually look at it. However, we actually have strong evidence that this is the case. This image is actually an artist's rendition of how we believe our galaxy appears. So we do believe we have a nice spiral-type galaxy and nicely pronounced spiral arms. Well, as people were first considering what could produce spiral arms like this in galaxies generally and in our own Milky Way, they noticed that it's along the spiral arm that we have the most stuff. So the disk contains the most interstellar medium and the most stars, and along the spiral arms within the disk, we also have the most interstellar medium and the most stars. Notice all of this kind of darkish stuff. That's the compressed interstellar medium forming into dark nebula. So because we have the most stuff there, it's reasonable to conclude that these are then held together because of gravity. We have the most matter, so gravity's pulling everything in. As we started to do the math on this, though, we realized that this couldn't be the case. If the spiral arm is held together by gravity, then everything in the spiral arm would have to move together. And as it moved together, it would naturally pull into the center of the galaxy. Think about a bunch of string just on the floor. If you grab the center of the string and you start twisting, after just a couple of twists, all of that stuff gets pulled and bunched up into a knot at the center. The exact same thing would happen to these spiral arms if they were held together by gravity. After just a couple million years, all of the spiral arms would be wound up into the center of the galaxy. Well, we know that our solar system is around 5 billion years old. We also know we're not at the center of the galaxy, so this idea doesn't work. It was a great first pass, I love the idea, but it's not right. The current understanding of where spiral arms come from is that these are actually caused by density waves. A density wave is a region where you have a higher density, and then in other regions you have a lower density. A great example of this is actually a traffic jam. So, for example, imagine we're driving north towards Salt Lake from Orem. As we approach Point of the Mountain, there's a traffic jam. No matter what time of day or time of year, there's always a slowdown as you go around Point of the Mountain. As you slow down, the cars get closer together, which means you've just increased the density of the cars through that region. Then, as you get around Point of the Mountain, now in this case it does depend on time of day, but usually as you get across Point of the Mountain, things speed up again. And because they speed up, the cars spread out, decreasing the overall density. This is what we believe is happening with the stars. That these spiral arms are high-density regions in an overall density wave. As the stars in interstellar medium push into the spiral arm, they bunch up together. Then, on the other side, they spread out. Now, as these things are moving into the spiral arm, it does compress the interstellar medium. And anytime we compress the interstellar medium, it's going to lead to star formation. If you bump that dark nebula just a little bit, so you increase the squeeze on it, compress it a little bit, then it's going to help those stars form. So as we look at other galaxies, so in this case, this is a picture of the Whirlpool galaxy because it looks like a whirlpool. As we look on the edge of the spiral arm through here, this is exactly what we see happening. On this zoomed in image, we see on the leading edge of the spiral arm, it is dark. This is dark nebula forming. Then, as we progress towards the side, we go from dark nebula to emission nebula, where the stars have formed and are beginning to energize, heat up the nebula, causing it to glow, and then on the other side we have a whole bunch of newly formed O and B blue stars. So what we see happening through the spiral arm really does fit with our ideas that spiral arms are density waves.